All right, so now we're going to take a look at, folks, looking at some functional groups for other organic compounds. Okay, so here's the real nuts and bolts. Here's the name, functional group, example, and a name of example. I think when I go through them, you'll see how it all works. The first one is a halo or halocarbon, okay? What do you think this has?
Carbon.
A halogen. A halogen. It definitely has carbon. So we've talked about hydrocarbons, which have only hydrogen and only carbon. Okay, those are hydrocarbons. Now we're going to start talking about other organic molecules that might have additional elements in there. Okay, so obviously a halocarbon or a halocarbon has halogens. All right, so the functional group, whoops, let me go previous. The functional group for a halocarbon is the R is going to represent, you're going to see this, it's going to represent a carbon chain. Alright, so whenever you see an R, it's like a variable for carbon chains. And then the X in this case represents, I'm going to erase that now that we're there, X is going to represent, in this case, any halogen. So it could be fluorine, chlorine, bromine, iodine, etc. Now those are the four. Usually don't have it with astatine. So chlorine, bromine, and iodine. Okay? So R represents your carbon chain, and then the X means, because it could be hydrogen, it could be chlorine, bromine, whatever. Here's an example. 1, 2, 3, and let's put a bromine off of that second carbon. Okay? Simple enough. Here's how I'm going to name it, and I think the way that I'm going to name the example will help you know how to name it. We would say the BR, yep. So the R is this carbon chain, and the X in this case is acting as the BR. Okay? So the name of this thing would be 2-bromo. Okay, bromo, and then a 3-membered carbon is propane. There you are. 2-bromopropane. What's that? Yep. So 2-bromopropane. Let me clean this up just a little bit here. It's fun to say. What do you think this would be? And then I'll erase it. So what if I have all this and it's a Cl? What would this one be called? 2-chloro butane, because but is 4. 2-chlorobutane. Now, you could have branches that are just regular carbons as well. Let's say I have a carbon there and a, let's make this a 5, and let's put a double bond, a 2-membered, an ethyl, and a Br. All right, let's name this one. Well, all we do is we look at our branches. Let me change the color here. Okay. Nope, this is still a halocarbon. This is a chloro. This is, of course, an ethyl. This is a methyl, and this is a bromo. Alphabetical, what comes first? Bromo. So 3-bromo. What's next? 2-chloro. What's next? 3-ethyl, right? Ethyl comes before methyl. 3-ethyl. 2-methyl pentane, because there's 1, 2, 3, 4, 5 pentane. Okay? Sweet is right. All right, let's move right to the next one. And I'm going to do a sheet, a review one on all of these. But so let's go right to the next one. The next one is called alcohols. Alcohols. An alcohol has your carbons. R is your carbons. And all alcohols have an OH group. So the OH is just off of the carbons. Here's an example. 1, 2, 3, 4. 4, and let's put that OH off of the second one, let's say. Who wants to, well, I'll take a look at it. The way that we name this one is this way. We call it 2-butane. We're basically writing butane because it's a 4-membered thing. We're not using the alcohol as a branch. It has a specific ending. It ends OL. All alcohols end OL. So 2-butanol. You've heard of isopropanol. Isopropanol is a generic way of writing 2-propanol. So 2-propan, you drop the E, so propane, OL, 2-propanol. This is another way of writing isopropanol, just like calling water instead of dihydrogen monoxide, you know. So 2-propanol. So all alcohols end OL. All right. The next type of functional group we're going to look at is an ether. An ether looks like this. An ether goes R, O, and then R. And I put prime here, ROR. So carbons with an oxygen with more carbons. All right, that's an ether. So an ether looks like this. Carbon, carbon, oxygen, carbon. Let's call it that. And you just simply name it going across. Eth talks about these two. Oxy represents the O smack dab in the middle. And then methane. So this is the methane. So eth, oxy, and then because that's a methane. So eth-oxymethane. Eth-oxymethane, that's an ether.
Will there ever be branched out?
I'm not going to do that. You could, but we're not going to. All right, so there's your ether. And the last one on these first 4 here are called aldehydes. You've probably heard of aldehydes.
Wait, where, on that last one?
Yep.
Where did, I'm just confused about how you name it.
Okay. We just, when we name an ether, we just go straight across. So, I found 2 carbons, that's an eth. Okay? Then we have the oxy, the oxygen sitting smack dab in the middle. And then whatever the amount in the last one, there's only 1, so that's meth, and it ends ane. So eth-oxymethane.
It doesn't matter what, like how they order it.
Well, you're always going to read left to right.
Right, yeah,
So I'll do that. I'll do another ether real quick. I'll do another ether just so we all see it. How about if I do 1, 2, 3, then an O, then 1, 2, 3, 4. How do we call this one? Prop, oxy, butane. Prop for 3, oxy sitting in the middle, but. If that was still an ether, yes. That's still an ether. Okay? No, we're not going to worry about it.
Is the oxy always in the middle?
Yep, oxy's got to be, well, and that's why the oxy's always in the middle, because look at your example. It's got R and then OR. An aldehyde, folks. An aldehyde is R with an carbon that has a double bond OH. A double bond O and then an H at the end. So the double bonding O is always on the last carbon. This is an aldehyde. The double bonding O is always on the last carbon. So here's an example. 1, 2, 3. Notice that I have a double bonding O and an H at the end. The double bonding O is on the last carbon. To name this aldehyde, how many carbons in it? So propan, just like a propane, but because it's an aldehyde, it ends AL. So propanal, very similar to propanol, like an alcohol. Notice the difference here, folks. OH here for an alcohol ends OL. This is also kind of like an OH, but of course it's a double bond OH, but it ends AL. Okay, so
Just count how many
propanal.
carbons.
Just count how many carbons. I got 3 propanal.
Wait, so is it? Would it ever be like? Would it ever be like carbons split up, not right next to each other?
Nope, there, because our R continues into this C over here.